Hi, in this session I'm going to discuss about the steam generator with you. The role of this steam generator in a pressurized water reactor is to transfer the heat from primary coolant to the secondary coolant to produce the steam. This steam drives the turbine generator for production of the electricity. Steam generator is a major component in a reactor coolant system. So let us go to discuss about the steam generator functions in a reactor. The first function comes like heat transfer. Transfers heat from the high pressure, high temperature primary coolant to the secondary side without mixing the fluids. Then second one, the steam production. The feedwater converts to dry saturated steam that powers the steam turbine. Then the pressure boundary. Steam generator act as a safety barrier between the radioactivity primary system and the non-radioactive secondary system, and it prevents the contamination as well. Then the last one, the coolant flow regulation. The steam generator ensures the flow dynamics in both primary and secondary circuits to maintain the reactor safety and efficiency. So next, here I am going to show you the a sectional view of the AP1000 steam generator. The steam generator consists of two integral sections, that is an evaporator section and a steam drum section. The evaporator section consists of vertically mounted U-tube heat exchanger, and steam drum section consists of the moisture separating equipment which removes most of the entrained water from the steam. In steam generator, steam dryers are employed to increase the steam quality to a typical minimum of 99.75% or higher, that is only 0.25% moisture. All pressure containing parts of the secondary side, with the exception of the tubes, are made of the carbon or low alloy steel. All surfaces in contact with the reactor coolant, that is the primary side, are clad with the stainless steel. And all steam generators are designed and manufactured under ASME BPVC section number 2, 3 and 9. We can discuss about the working principle of the steam generator. We can classify it into two, the primary side and the secondary side. The primary side we can call it as like hot side as well. In this side, the reactor coolant, the temperature about 310 degrees Celsius, which enters to the steam generator through the primary inlet. Then this reactor coolant circulates through thousands of U-tubes and exits at a lower temperature about 280 degrees Celsius. In another side, the secondary side, we can call it as steam side as well. In this side, the feed water about 230 degrees Celsius, which enters into the shell side, and this absorbs heat from the U-tubes and turns into steam about 275 degrees Celsius. There would be steam separators and dryers which will help to remove the moisture before sending the dry steam to the turbine generator. Reactor coolant heated in a reactor moves through pipes to the steam generator. Hot reactor coolant flows through approximately 13,000 U-shaped tubes within the steam generator, making a full circuit as 320 degree hot reactor coolant moves through the pipes. It heats feed water outside the pipes. The heated reactor coolant in the pipes cools down after transferring heat energy to the outside feed water and leaves from the rear pipes. This reactor coolant is then sent back to the reactor through the pipes. After turning the turbine, the condensed feed water re-enters to the steam generator through a sideline and moves downward. This reactor coolant is then sent back to the reactor through the pipes. After turning the turbine, the condensed feed water re-enters the steam generator through a sideline and moves downward. The descending feed water passes through the space between the pipes, acquiring heat from the hot reactor coolant flowing in the pipes, and gets transformed into steam. Steam contains some liquid particles which have not yet reached the gaseous state. These liquid state steam particles are called moisture. When the steam in this state enters the turbine, it can cause damage to the turbine blades. To prevent this, there is a device above the steam generator that separates moisture from the steam. Inside a yellow cylinder, there is a device shaped like a windmill that causes the moisture to condense back into the water. Steam with most of the moisture removed, resulting in steam that is almost 99% gaseous. The steam produced in the steam generator passes through the pipes and enters into the turbine generator and produce the electricity. Next, we can discuss about the importance of steam generator in a reactor operation. The first importance we can say like the steam generator maintains the reactor thermal efficiency. Using the steam generator, efficient heat transfer ensures the optimal electricity generation. And the second one, it steam generator serves as a safety barrier. The steam generator prevents the radioactive contamination from reaching the turbine. The third one we can say controls reactor power output. The steam generator pressure influences primary system temperature and the reactor power. Then the last one we can say like the steam generator acting as a heat sink during the shutdown. The steam generator removes residual heat from the core through the natural circulation when the pumps are off. The next, I'm going to brief you about the common issues occurring in the steam generator and their maintenance. The main common issues are occurring in the steam generators are tube degradation and falling and deposits. The last one and the very most important, the steam generator tube rupture. The tube degradation is occurring due to corrosion, fatigue and wear and which leads to the leaks. So we need the regular inspection and plugging of defective tubes to avoid the falling and deposits. The second one, the falling and deposits, which occurs due to the impurities in the secondary circuit and which will lead to the scale formation and it will cause to reduce the heat transfer efficiency. Then the third one, the steam generator tube rupture. This is like a crack in a U-tube allows the radioactive primary coolant to the secondary circuit. Then let's go to conclusion of the topic on the steam generator. Steam generator in a PWR is a critical component for heat exchange and power generation and which ensuring the safe and the efficient operation of the nuclear power plant. The proper maintenance, water chemistry control, and regular inspections are essential to prevent failures and ensure the long term performance. Thank you.